because the key here with factoring is knowing what method do I even use. You need to be able to recognize it, right? So right now we're just kind of in the mode of like practicing how to factor, right? When we start getting to like the CPM stuff, now we're gonna actually start applying it and putting it into an equation and then graphing it and then figuring out what's the root and where does this situation start at? Where does it end? You know, in 10 years, like how much money, you know, we're gonna start getting to those problems, but right now this is just kind of practice on how to break these problems apart, all right? How to break them down so we can find important information from them. All right, so the first thing we looked at was using the GCF, okay, which could be every problem you work on. Okay, you could be doing greatest common factor with all of them. Okay, then there's box and diamond. So GCF, you are first looking to see if there's a common factor between every term. And you can do that with every problem you work on. Always do that because one, you might get stuck somewhere if you don't. And two, if you can factor out a common factor, especially when the numbers are bigger, it's going to make it a lot easier for you, okay, to figure out the problem, right? Because, I mean, if you factor out, let's say a 3 here, that 168 all of a sudden becomes a lot smaller number to deal with, all right? Okay, so this, we're doing greatest common factor, and we were also doing the box and diamond. So this one, for example, we factored out a V, and then after we factored out a V, that's what it was, right? Okay, I factor out a V, now I'm using the box and the X. So here I've got -30, V squared, and on the bottom I got -7. So my two numbers would be 10 and 3. The 10 has to be negative. So I can go, because that's just a 1, I can go straight to my factors. So I get V minus 10, and then V plus 3. Okay, so that's the X, right? And then maybe I've got a problem that looks like this. Now let's say, again, you guys don't need to take notes on this if you don't want to. I'm just kind of reviewing a little bit. So this one I would set up with the X, right? So 3 times 2, then the middle term. So this would be 6 and 1. Now the difference between that and that is I have a number bigger than 1. So I can't just stop here. Now I've got to go to the next step and use the box to factor it out. So remember, my first term goes in the first box, my last term goes in the last box, and then the numbers you found go here and here in the other boxes. And again, it doesn't matter where those go. I can put the 6 here or the 1 there. It doesn't matter. Now, if I'm looking at the 6 and the 3 going up and down, the common factor between those is 3x. So that means that the common factor between these two going across, which would be just x. That's how I know to put the 3 on top. Then 3 or x times 1, 3 times x times 2. And then I end up with 3x plus 1 coming from the top there. Because remember, that's a positive 1. So make sure you always put the sign. So if that's a negative, you want to make that a negative. And then x plus 2. All right, so that was the trinomials. That's when you got 3 numbers. Okay, so if I'm thinking greatest common factor. I got 3 numbers, so now I got to do the x in the box. Now, what about if I have, we just talked about this a minute ago. What if I have 4x minus 25? Well, those are 2 perfect squares. So now I can do the shortcut. Okay, square root the first, square root the last, and then the signs are plus minus. Okay, so that's what we've done so far. And then to go a step further, if I say solve it, and all of a sudden it's equal to 0, now you got to give me an answer. You got to give me a solution. And you got to figure out, okay, what do I plug into x to give me 0? Well, in this case, it'd be, that's positive, so I put negative. And the shortcut with these ones, when you have like 2 numbers here, I take the second number, put it on top. The first number goes on bottom. Okay, so it'd be 5 halves. Or like that one would just be -2. All right. Okay, so again, I'm just reviewing it. I'm not trying to like go in depth on that, but I just kind of want to say, hey, you got to recognize, what do I do in each situation? Okay, quick questions about those before I get into grouping. Okay. All right, so let's talk about factoring by grouping. All right, so the problems you guys are going to see don't have two numbers. They don't have three numbers. They are going to have four terms. I have four terms this time. Make sure that you guys can see everything. Okay, so when you have four terms, the key thing is one, two, three, four numbers. And the first one will always have it, the order of the exponents will always start at some number, like could be 3, could be 4, and they'll go down from there. So like 3, 2, and obviously I don't have to write the 1, but there's a 1. Okay, and then you could say 0, right? Or it could be like this. Could be 4, 3, 2, and then that. Okay, so it always be four numbers, and then you'll see like the exponents go down in order like that, okay? All right, so first step on these. I'm still gonna use that same idea of, first I wanna check, is there a greatest common factor between 8, 7, 24, and 21? 8, okay, can I divide 8 into every number? Like I'm looking for one number that I could, is there a number that I can divide into 8, 7, 24, and 21? I can divide 2? No, because these are both odd. 3? No, that doesn't work for this one. Or 7. So there isn't. There's nothing I can do. All right, so I'm just saying check first, okay? So I'm going to go straight to the first step, which is split it. So I split this in half. All right, so I'm basically going to, I have this, the left side and the right side split in two. The first thing I want to do is find the GCF, the greatest common factor between these two numbers. So what's a common factor between 8 and 7? What's that? A or 8? A squared, yes. Okay. Now, if I'm looking at just the numbers, just 8 and 7 itself, the common factor is 1. Okay. Because some of you guys might be going like, well, wait, there's nothing. No, there is. Every number has a common factor. It's always 1. But there's no other number than that. Okay. So if there isn't, I just write the common factor between the variables first. Okay. Because this has a squared, this has at least 2, so they have that in common. All right, now I'm going to, after I factor that out, a squared times what would give me that term? 8a. What would be the second term here? Minus 7. All right, so that's the first step. Find the common factor between the first two numbers, just the first two. Then what I do is I take this part of the factor and I repeat it over here. So I literally just carry this over here. Now I work the other way. Now I say, what number would I multiply here times 8a to get the first term? So what number times 8a gives me negative 24a? Negative 3. And then check, does negative 3 times negative 7 equal positive 21? Yeah. Okay, so that works. All right, so now here's how you set up your factors. This is always going to end up giving you two separated factors. In the first parentheses, what I do is I take the first terms and they become the first factor. So a squared, and then basically your GCFs become your first parentheses like that. Okay, a squared minus 3. And then what I do is I take one of these pairs, you see how they're matching? I only take one of those and that becomes the second one. And that's it. So literally, just to repeat myself, I look for the common factor between these two numbers, which was that. And remember, look for the greatest common factor, not just any factor, but the greatest, the biggest number you can divide. Yeah. Yeah, you want to split it in half because you're only going to work with these two numbers when you do the first step. Okay, so I just do that for reference, just to remind myself. Okay, I'm only doing these two numbers to start with. Okay. All right, so now let's look at another example. Okay, so now let's say I got 90n cubed minus 60n squared minus 105n plus 70. All right, so for some of you guys, this gives you anxiety. You start seeing those numbers, they start getting bigger, and you're like, oh, God, please, Jesus, don't do it to me. All right, but it's okay. Just take a breath. You'll be okay. All right, first thing you want to look for is a what? A common factor. 90, 60, 105, and 70. What jumps out at you? What's the common factor here? What do you think? Okay, 5 works. Now, some of you guys might go 10, but 10 doesn't work for which number? Yeah, because I know you see the 90, 60, 70, but just remember that one wouldn't work, right? So 5 will work. So let's factor out a 5. So now, if I divide that by 5, just bring out my calculator here. Do 90 divided by 5, get 18. And cubed. I know 60 divided by 5 is 12. 105 divided by 5, well, 100 divided by 5 is 20, so that's just one more, 21. And then 5 divided by 70, that's 14. Okay. All right, so now when I do the split, now I'm just working with these 4 numbers. Okay. Now, in the end, when I get to those last 2 factors down here, don't forget that you factored out a 5 to begin with, so you got to include that, okay? It doesn't just go away. That's still part of the expression. It will no longer be equal. This will not be equal if you don't include that 5. All right, so first thing, we're going to split it just like before. Common factor between 18n cubed and negative 12n squared. What would it be? You can always just start with the 18 and the 12. What's the common factor there? Greatest common. Bigger than that. 6. Okay. Is 8 a good common factor? Or 9? Does 9 work? No, just 6. Okay. So 6 is a common factor here. And then what's in common for the variables? N squared. All right. So now, again, just like we did in the last one, we got to figure out, okay, what are the factors here now? So 6n squared times what will give me that term? 3n. And then 6n squared times what gives me this term? Minus 2. All right, so now I jump over to here. What do I write inside there? Right, you just bring this over. These will always match. So whatever you get here, guys, always repeat that right over here. So you basically are starting with this and now using that to find that common factor between these 2 numbers. So what would it be on this side? Good, negative 7. Because negative 7 times 3n, that gives me negative 21. Negative 7 times negative 2 gives me positive 14. Now I take those 2 numbers. They go in the first parentheses here. And then I take one of the matching pairs and they go here. And then that could be it. Now, the other thing when you're working on these is double check, can I factor anything at the end? Is there anything factorable here or here? or in one of those factors. Are they factorable? Now, in this case, no. Now, if you guys remember, we were talking a minute ago, if I have like 9x squared minus, I don't know, 25, those are two perfect squares, right? So check. Do I have two perfect squares in one of those? If you do, then you might be able to factor it even further, okay? All right, so I'll pause this for a second. Some of you guys, okay, so now, bring this down just a little bit. Okay, so now I'm gonna start with 54x cubed plus, actually, you know what? I'm actually gonna do x to the fourth. X to the fourth times x cubed, oh, sorry, minus 24x squared, and then minus 16x. Okay. All right, so first GCF. Is there one? Is there a common factor there? If there is, what is it? Is there a number I can divide into all those coefficients? There should be an obvious one at least. 2? Okay. Is there a variable? You said a variable 2? Yeah, so we could try 2 and let's see if that works. All right, and then yes, and then now they said that all of them also have an x term. So let's try dividing out 2x, and see if we end up with terms that have nothing in common after that. All right, so first we're going to divide that. So we get 27 x cubed, because that was to the fourth. So now it's x times x to the cube gives us x to the fourth. So basically, as you write these out, you're going to bring down that exponent by 1. Okay, so then divide this by 2, I get 18 squared. I divide this by 2, I get 12. All right, 12x. And then the last one, divide that by 2, I get minus 8. Okay, now look at those 4 numbers. Is there a common factor? Did we leave anything out? Can they all be divided by 2 again? Nope, not that one. How about 3? Nope, not that one. 4? No. 5, 6? No. Okay, so that's it. All right, you just want to double check. Did your factor actually reduce it down to the smallest possible? Yeah. Yeah, once you've got that greatest common factor, then make the split. Okay. Now here's the deal. You could actually go ahead and split it on the first step. The problem is that in the end, you're going to have another common factor inside those parentheses again, and you're going to have to factor again. So do it in the first step, and it'll save you some time. Also, I mean, the smaller the numbers are, the faster you're going to go as you go through these. All right, so let's split it first. So common factor between 27 and 18. The greatest common factor, not just any factor, what would it be? Greatest. Think bigger. 9. Now let's actually do it without, let's just say we don't know it's 9, right? Let's go ahead and work through the steps. I'm going to show you what happens. All right, so it's not just the 3, but it also x squared in common. So don't write this down if you're writing this down at home, by the way, because I'm doing it wrong on purpose. All right, I get 9 here. Here I would get, what is that, 6? And now let's bring that 9x plus 6 over here, and I'll show you what happens here. So now you're saying, what number times 9 gives me 12? And you're like, wait, that doesn't work. There's nothing. Or what number times 6? I'd have to multiply a fraction, but I'm not trying to do fractions, right? So that means when in this step over here, you didn't find the greatest common factor. So if you end up with something like that, go back here and go, oh shoot, I don't think I found the greatest common factor. All right. So let me redo that. So we know it's 9. So now 9 times 3x and 9 times 2, or 9x squared times 2. So now I repeat that, bring it over here, 3x plus 2. And now let's see, what number to kind of multiply times 3x to get negative 12? Negative 4. All right, so now I'm ready to bring it down and write out the factors. The first one, I take, remember the common factors, and that becomes the first factor here. And then I take one of the matching pairs. All right, now once you guys take a look at that, is there anything else I can do? What could I do? 2x? Oh, yeah, that too. Bring that down. Is there anything else I can do? I can factor this more. What part of it? Which ones? Yes, those two numbers are perfect squares, and look, they're subtracted. So I can do that shortcut to actually factor this part out even more. So now I'm going to rewrite that 2x, and these are about to be factored into 2 separate factors. Now the 3x plus 2, I can't do anything with that, so that just remains the same. So now what would be the first terms here? Okay, 3x. And what are the second terms? 2. And what are the signs? Plus and minus, or minus plus, I don't care, it doesn't matter. All right. Now, take a look at it one more time. What do you guys notice about the factors? What do you guys see? Are they all the same? Well, not all of them are the same, but some are. Which ones are the same? Right, the sum or the 3x plus 2, because that's not the same, right? If you guys remember, how can I write this differently instead of writing 2 of them? Right, what's that called? What's that thing? An exponent. So if you get any time you get 2 that repeat, then you can just write squared like that, okay? Just to simplify your answer a little bit. All right, so again, the point of this problem was that first, I had to find a common factor in that first step to kind of reduce things down. Let me zoom out just a little bit so we can see everything. There we go. Common factor, we split it. I got my 2 factors. And then here I noticed perfect squares. So then we did the difference of squares shortcut there. And I could have actually just stopped right here. I mean, if you guys put this, you're good. Okay, this is just me being cute. All right. All right, so I mean, you don't have to do all that extra, but I mean, this is what we're looking for. That's the meat and potatoes right there. All right. If you end up doing this, great. Okay, you guys at home, if you have more questions or anything else you need me to go over, feel free to stay. Otherwise, you guys are good to go. I'll see you guys mañana, tomorrow, same time, 10:40. Have a good day. See you guys. All right, what about you guys? You guys got any questions on that stuff?